It's mathematician persona here. So today we're going to be doing something still pretty simple. We're going to be doing some multiplication of three integers. And you might notice these are pretty big integers. These are two-digit integers, all of them. Count them, all of them two-digit integers. Now this should be pretty tricky to do in your head, which is what I hope we will be able to do by the end of this video, but it's also like pretty admittedly it's pretty easy if you want to like just I don't know, plug it into your calculator. You can be all 11 times 12 times 13. You can plug that in, you can hit equals. Hit equals, but I'm not looking at it. I actually accidentally hit clear. Okay, I hit equals. I'm not looking at it. There, so it's out there. The calculator's right there, off screen. I'm not looking at it. You gotta trust me. You can't see my face, so it's not like I could be looking at it right now. I could be looking at anything right now. Right now, I'm looking at some famous Amos cookies. There's no way of you proving that. There's no way of you knowing that. But this is the truth. So today we're gonna look at 11 times 12 times 13. Now, a good way of looking at this is seeing what they are related. So 11, you might notice, is 11. We're just stating that to be obvious. 12 is 11 plus 1, and 13 is 11 plus 2. Now, this is obvious, but it's good to be explicit about these types of things. But I can actually do one better. This is actually not the right way of doing things, because here we have like just numbers just getting bigger. Like if we were to scale this on, if we were to have 14 here, 11 plus 3, which is tricky, and all of these plus 1s, we're going to multiply these things, right? We want to add as little as possible if we're multiplying things, because when we're multiplying and adding together, it's just ugly. So the best way of doing things is actually to redefine everything in terms of 12. Because if we have 11, we get 12 minus 1, and for 13 we get 12 plus 1. And this is great. We have a symmetry here. So like anything that we can prove for 11, we can probably prove for 13, give or take a minus sign. So this is a really good way of doing things. And well, this right here could be a more general thing. So this 11 times 12 times 13 can boil down to x minus 1 times x plus 1 evaluated at x equals 12. Okay, that looks like we've just taken a simple thing and turned it into a more complicated thing. But the more complicated thing's also more general. So we can actually move it around and see what it is in the general, and that's actually going to help us in this specific case. So, just moving things around just to be more pretty, I suppose. Yeah, we'll do it this way. X minus x times x plus 1. Now, these two things are very special polynomials right here. They're very special. You got x minus 1 times x plus 1. Now, I'm going to FOIL this once, but then I'm never going to have to do it again because it's the general case. If it was the specific case, I wouldn't be able to do that. You got x squared, and then you use inside you got minus x, outside you got positive x, and last you get minus 1. So these minus x and the positive x cancel, and you're left with x squared minus 1. This is great, we got no linear terms. So this quadratic only has two terms. That's nice. So then if we multiply that by x, that's pretty trivial. That's just x cubed minus x. Now if we plug in our original 12, we can get 12 cubed minus 12, which is, of course, 12 cubed is 1728. You can observe this by just knowing it. Minus 12, really, how could you not know that's 1728? That's not a life worth living, I'd say. So 1728 minus 12, that's just 1716. And if we look at our calculator, buddy, what-ho, 1716. All right. So the good thing about this, the reason I really like taking something this simple and expanding it so you can actually like do things like this in your head, like the only reason I'm making this video is because I actually did this in my head and people around me were amazed. because I'm just so good at math and everyone loves me in the real world. Yet, it's great. It's a gift. Truly, truly wonderful. Whew. Yeah. So, great thing about doing things like this in just knowing these things, knowing these very basic things, but moving them around in your head like this. The great thing about this is like it's just like it scales. It scales. You know, that's great. That's fun. If you want to do something like 15 times 16 times 17, all you gotta know is that's 16 cubed minus 16, and 16 cubed, well, that's just 4,096 minus 16. That's 4080. Yeah. Don't even need to check the calculator. That's pretty obvious. But and if you wanted to do something like more complicated, like 55 times 56 times 57, well, that's just 56 cubed minus 56. Now, I don't remember what 56 cubed is, but instead of calculating all of these terms, you can just take 56 to the 3. Whoop. 56 to the 3, and you get this huge number, 175,616. Subtract 56. I'm going to write that just to be explicit. That's 175,560. And just to be safe, 55 times 56 times 57. What do you know? I just think it's beautiful. It's beautiful. And you're beautiful. You're beautiful. If you're beautiful, please like the video, and please comment the video. Do not subscribe to the video. Subscribe to the channel. Thank you. Take care.